is the sum of all positive numbers truly equal to negative 1 over 12? Well, let's see. So first we're going to set a is equal to 1 minus 1 plus 1 minus 1, alternating like that. And we're going to have 1 minus a, which is equal to 1 minus, in parentheses, the same repeating series. And this just cancels out to 1 minus 1 plus 1 minus 1, which also conveniently equals to a. So now we have 1 minus a is equal to a, and we can make that 2a equals to 1, and divide by 2 to get a is equal to 1/2. Now we're going to introduce a new series b, which is 1 minus 2 plus 3 minus 4 plus 5, all the way on and on. And we're going to subtract a from b. So we get b minus a is equal to 0 minus 1 plus 2 minus 3 plus 4 and on. And one thing we can notice about this equation is that it's just equal to negative b. So from this we can get that b minus a is equal to negative b, and we can just add b on both sides and add another a to get 2b is equal to a, which is equal to 1/2. And next we can just divide both sides by 2 to get b equal to 1 over 4. Now we're going to introduce another new series, s. And s is 1 plus 2 plus 3 plus 4 and on, which is just the sum of all positive numbers. And we're going to subtract b from s to get this equation listed, which conveniently is equal to 4 times, in parentheses, 1 plus 2 plus 3 plus 4, which is also equal to just the sum of all positive numbers. And since we know that s is equal to the sum of all positive numbers, we can get s minus b is equal to just 4s. And now we just have to subtract an s from both sides to get negative b is equal to 3s. And we can just divide both sides by 3 to get s is equal to negative b over 3. And since we know that b is equal to 1 over 4, we can get that s is equal to negative 1 over 12, therefore proving that the sum of all positive numbers is equal to negative 1 over 12.